Okay, so we'll move on to our second speaker now, Serrie-Chapman, who's a requirements engineering consultant from TVS. Serrie's topic is safety, requirements engineering, and proof of implementation. Serrie has 15 years experience working first in automotive pre-silicon semiconductor verification, and latterly in the realm of requirements engineering, helping to attain safety compliance across the requirements to test and verification gap. She is currently working on a European project, the Crystal interoperability project with automotive companies such as Daimler, Volvo, AVL, Valeo and Fraunhofer, and also with the RAL domain with SDS RAL driving a tooling solution with TVS's asureSIGN and AsureView. She is also involved with a UK NATEP project, which is extending the solutions from automotive to avionics and the system and software domain as well. So I'm going to hand over to Serrie now.
Hi. Right, okay, do I get an extra minute? Okay, so I'm going to just go through the safety standards because, as you know, as Mike just said, I'm working on a central project, actually, with Crystal, which has got 70 partners. The main of the standards generally come out of this generic standard, which is the 61508, which is industrial and energy. Nuclear is obviously a very old standard. They're not actually on that Crystal project, but they are on a lot of other Crystal projects, a lot of other Artemis projects. If you look at the dates on these, a lot of these are being updated quite often. So avionics, they actually split their standard between 254 and 178. One happens to be hardware and one happens to be software. They've just updated with the 178C in 2012, and that's just starting to impact them now. The rail, they're very, very good on their implementation of safety. They've got the 50128, and that's software for railway control and protection systems. A lot of theirs is communication systems about communicating where things are within the tunnels and stuff on their safety. Medical got hit the same way that ISO 26262 did on automotive, really. I don't think they were quite expecting it to hit them so hard. But this is a lot on, so on the Crystal project, they're doing a robotic arm. It's not so much about whether it can go in and save your life, it's making sure it doesn't hit anybody when it goes there. Bit like airbag, it's not whether it works, it's whether it doesn't go off when you don't need it to. Then the ISO 26262, which everybody has probably heard of. So this is a less than 3.5 ton one that came out in 2011. It is about risk mitigation, really, hazard analysis and risk mitigation. They've just started the rewrite this year in January. It will be coming out in January 2018. There's a lot of security standards going into this one. So there's about 3 or 4 security standards out there that are being written at the moment. A couple of them are vehicle to vehicle, some of them are vehicle to external, so talking to lampposts and things like that, or other signals, and also some visualization things. So a lot of this visualization, radar, satellite stuff is also going to be added into it. When I did my ISO 26262 standard, the whole of Triumph were there because it's going into motorbikes, and it's also going into plus 3.5 tons. So Volvo are very advanced on this. So what I'm going to discuss is the safety culture. So there's one thing about putting safety in and making sure that you've got your you've got your degrees of independence, etc. But it's actually a big part in there about building up a safety culture, and I would say it's possibly one of the most expensive parts about implementing it. I know, Woody, we were discussing it last week. So the safety culture, it says that it's got to create, foster and sustain the safety culture so that you support and encourage the effective achievement of functional safety. What it's saying is that you have to have an awareness of safety, so everybody in the company has to have an awareness of safety, even if it's just in relation to what you're doing. Proving, you have to have processes to prove your safety, and you have to prove them by periodic process and audits. Now, your audits can be internal, but generally they have to have a certain amount of independence. So if you look at the standard, there's certain amounts of audits that you can do internally, but with different teams or with different groups or with different branches, and then you have to go external. So the proof of your processes, and it's very much process and documentation driven, this standard. Rewards, and this is one I don't think that I've actually seen anybody implementing, is that your reward process has to be driven by safety and not time to market. Generally, bonuses in the past have been driven by time to market and implementation, not by safety. I don't know how people are proving that because I haven't seen it out there at the moment. Timely. Safety culture and processes were integrated throughout the product lifecycle. This isn't a sign-off tick box. You can't just get to the end and say, oh, look, yeah, okay, it's safe. I know certain companies as well that have tried to do that and it doesn't work. This isn't an add-on. You've got to prove that you had a safety culture from the beginning. Independence. So the independence is not just in your design partitioning, so that you haven't got a single place that you can actually cause problems. There's also parts in there about test pattern independence and also in assessment. So this thing about that it's got to be independent, so you can't assess your own and say I've reviewed that and that's fine. Resourcing. It says that you have to have proven to have the required resources of sufficient competence to actually implement the safety. I suggest that probably quite a lot of teams don't really feel they've got the resources currently in the recent climate. Continuous improvement. So not only that you do your lessons learned, but you actually prove that you've actually implemented something from your lessons learned. So there's one thing that people sit around and say, what have we learned from this? But you've actually got to prove that you're actually implementing something to improve it for the next time, and you didn't just sign it off and walk away after bitching about each other for a couple of hours in a meeting. Define, traceable and controlled process. Now it states that you need to have these in the following areas. So management, you have to have safety management. They have to ensure that the culture and the adherence, the discipline, defining the roles and responsibility, distributing the development and documenting and reviewing. That's the part of the management. So any managers here, that's your job. Engineering, this is good safety design such as freedom from interference, fault injection, ECCR correction, etc. I think most of us are aware of that. Development interfaces. Now in the avionics standards, 178 and 254, they have separate ones. This one's very, very clear about having the hardware-software interface. There's an entire section on it about how to communicate that and how to document it. We also have to really look at the processes. So if you're going pre-silicon to post-silicon or IP to SOC, you might have different processes. And what part of the work that we're doing on this European one at the moment is about how these processes are different and how you actually have to recognize where you are in each of the process when you're going across these boundaries. Verification, it's a bit weird on verification, to be fair. It doesn't have any clarity, it doesn't tell you any tooling, but it does say that you can use common methodologies, but it has to be documented and proven, and that's really about as much as it says. To be fair, with verification tools, they do move quite quickly, so I think specifying anything too exact would be difficult in the standard. The validation, I know that for silicon validation means something different. A lot of it is about validation of the correctness of your requirements, but it's also to validate the evidence of compliance with the safety goals. You've now got two things, which is a functional safety audit, and this ensures that you have implemented the processes that you have put in for the safety culture, and then you have the safety assessment, and that's saying that you got it right. When you said that was an ASIL D, did you say that correctly? So you've got two types of audit. One, are you following due process, and are you actually correct in what you've actually analysed? So stage one is what are we actually looking to do. Okay, I'm going to really run through this. So requirements management, we've got semi-formal notations. There's massive description in there. When I actually spoke during my training about what it was, they said, oh, we expected pseudocode. In reality, they're pushing towards modelling. So there is an MBSE, model-based systems engineering groups, or boilerplates. So semi-formal notation for ASIL D is quite important. The next thing, it does say verification by inspection. Again, they've talked about executable models. So models is very, very big in here. Proof of implementation, we have to ensure that the requirements are well written, correctly defined, normally through review, implemented and proven to be implemented. And to do this, we can do it by test, by review, by justification, or by documentation. So what we've moved on to is looking at requirements-driven verification and tests. So we have requirements input, multiple tools. We can have a quality gateway, so there are some tools out there that can check the quality of your requirements, check that they are semi-formalized. And we're working with a couple of these companies on the project. And then there's test management, which you can have Excel, Word. There's a lot of domain test managers out there from Cadence and Mentor, etc. So there are multiples of these. And then you should map those down. The traceability aspect means that you should map them down. One of the issues that we did come across was that we ended up with lots of variants and lots of different types of testing, and they all had their own test management tools. So where TVS has actually moved towards is to try and get some auditability on this. So on this particular slide, on the left, we have either test plan or requirements that can then be refined down through the hierarchy. These can then get mapped to test and then to test results. So rather than having to automate, a lot of the clients that I'm speaking to seem to manually put their analysis of the test directly into their requirements management tool. Now that's a bit dangerous because you can write anything in it. Yes, we could probably go and find that out in 20 years' time, but if they're dead and we don't know the reasoning behind somebody justifying something by just changing a no to a yes. So this is all automatable to save us that problem. The other big thing is to ensure that the information gathered is reproducible. So you need a lot of metadata from out of your change and configuration management tools. You have to be able to replicate this in 20 years' time. If somebody's dead in the car, you want to know why. You want to go back and test it with the latest tools. You want to re-verify it and see whether you actually falsely put that in as a pass or a fail. So this, again, is about culpability. The other thing we had is about this cross-domain. So when we're actually trying to speak and get trust within the tool, we built this tool, AsureView, which is just coming up for release. And this will allow you to manage your data. So if you had lots of different IPs, you could manage them over different variants and compare the different ones. If you're a project manager, you could actually have the entire product in there, and then you could manage it and look at the different groups and see how well they're doing. This is a live status of your coverage and whether your results, whether your requirements have been implemented across the different domains. And that is it. Is that within time? Right, okay. You shouldn't have sped me up. You gave me a 5-minute sign.
Any questions? Any questions on that? Yeah. Any from Bristol?
By the way, we are a TRL1. We did actually analyse that. We are a TRL1. However, we are getting qualifications for our tool set for the 254 because they actually require a different qualification set. They don't actually. For 254, 254 is for avionics. They have different rules. They're a lot more review-based as well, and less automatable. I think in reality, the automotive sector, with its time to market push, and having to put the requirements engineering in, has pushed in a lot more automation because you just can't afford to manually do it. Whereas before in avionics and rail, etc., they've got a lot more manual process going on. And you could do the whole thing through manual process, but it's going to cost you a lot of people. So yeah. Oh, hi.
In terms of requirement management, as part of the ACL A, B, C, D, is that defined exactly to be checked and qualified or certified? How does it work?
What, for the ACL A, B, C, D? Yeah, for grading the actual requirements, yeah, that's very, very clearly defined. The actual standard itself is very, very good in driving you to write requirements for safety. It literally says, what are your problems? What's the worst that's going to happen if this happens? How would you mitigate that? How would you stop it from happening? Is it a single point of destruction, basically, and how many people is it going to kill? And so it's very clever about that, but it also talks you through using fault tree analysis, etc., to turn around and make sure you have got the independence and that you design right for safety. So the whole safety itself, which I haven't really touched on, is very, very clever at leading you into a safety design.
Is that something that a company can do internally, or does it have to be audited by an independent external?
You have to have a final external, generally. But in reality, there are statements in there that if you've got a customer-supplier interface, your customer can at any point come in and audit you. So there's things that's to prove that you've got the safety culture all the way through. So yeah, there's certain things that you can review one another, a bit like extreme programming type things, but it states that at different ASIL levels you have to get more independence.
Just one final question if we have time is, because presumably this is to do the final product. Now, how does that kind of go all the way down if you're an IP provider, for example, because you only give the IP? somebody else to the association?
There is a HARA set up, which is a hazard risk thing, which actually goes through and you have to sign off between different companies. You do have issues because it's an expensive process. If you're a very small component, it might be too expensive to you. We've had that issue already. You might need to bring them into your own safety culture if they're supplying to you, in which case you then take on the mantle of looking after their safety through your tooling. It's required. It's part of the HARA if you look at the top level documentation. Yeah.
You've got 2 questions online as well, so it was good to finish early. So the first one is from Donald McCarthy, or Paddy as we know him. Why would aviation be looking to automotive when they have been in safety longer?
Because they've done it much more manually and they're starting to have problems with the ecosystems and how they've changed their processes over the years. So they're moving much more towards product families. They've used big cumbersome tools in the past and it's been costing them a lot of money and they're now aware of that. The guys that are inside, so Airbus are in the Crystal project, they've all just implemented a whole OSLC interoperability between all their toolings and then realised they wouldn't be able to get audit with it. But they are really struggling, and it's a very manual process, and they're also tightening up the standards. So 178C has just come out, and that's a tightening up of a standard.
Just as allegedly against Airbus. It's,
allegedly. Yeah. Well, they're on Crystal. No, they're doing all right.
And then one more question from Ankit Garg. ISO 26262 said 2018 in the slide. Does that mean it will be enforced in 2018?
Normally they kind of get implemented and they get accepted. So I've noticed that for the 26262 there's some security standards coming in from the US and some different ones coming in from the EU. It normally then goes through a regulatory board. So I think it's getting released. When I looked at some of the other standards, they got released in 1 year and didn't really get mandated until the year after. So it depends on the process. I noticed it had to go through some US board, one of them, and it took about a year to go through, and then it was mandated. It's generally an acceptance process. I mean, most of these standards seem to say that things are highly recommended, and they don't actually mandate anything, so they do give you a little bit of process, a little bit of room to negotiate.
Okay, thank you.
Okay.
There's one final comment from Paddy saying thank you.
Right, okay. Thank you, Paddy.
Thank you. Thank you from everyone. Thank you.